Lesson 10.3, Operations with Radical Expressions. In this video, you will learn to add and subtract radical expressions and multiply radical expressions. So, first thing we're going to do is we're going to look at this and they have the same radicand. So remember, the radicand is part inside the square root. So in here, all of these have a 5 in the radicand, which means there's like terms. So I want to add and see how many square root of 5s I have. I have 6 of them here, 2 of them here, and negative 5 of them there. 6 and 2 makes 8, and then 5 less makes a total of 3 square root 5s. It's almost like you're thinking of that square root as it was like a variable x. So like if you had 6x plus 2x minus 5x, you would say that that is 3x. It's the same thing, except instead of x, we have a square root. And that's what we do when we have the same thing, the same term. So looking at this, here we have a square root of 2, and here we have a square root of 2. So those are our two like terms. So 7 square root 2 minus 6 square root 2, 7 minus 6 is 1. So I'm just left with square root 2. And then I have a square root of 11 and a square root of 11. So 8 and negative 4 makes a total of positive 4 square root 11s. And now that's as simplified as I can go, because 2 and 11 both can't simplify any further. So, and they're not like terms, so they can't be combined. What if I have all different square roots? So right now, looking at this, it looks like they're all different terms and they can't be combined. But what I want to do first is go through and simplify square roots. So I'm asking myself, are there any perfect squares that go into these? So in 27, 9 times 3 is 27. So I can say this is the same thing as 6 times the square root of 9 times 3, which is going to become 6 square root of 9 is 3, so 6 times 3 is 18, and I still have that square root 3 on the inside. Now I'm looking at the next one, 8 plus the square root of 12. Well, the square root of 12, inside 12, we can say that's the same thing as 4 times 3. And now I can say this is the square root of 4. So square root of 4 is 2 times that 8. This is going to become 16 square root 3. And then 75. 5 goes into that. So I can say this is the same, or 25 I mean. This is 2 times the square root of 25 times 3. So I can say this is the same thing as the square root of 25, which is 5 times 2 is 10 square root 3. And now, if I'm looking at each of my radicands, they're all 3, which means that these are all like terms. So 16 plus 8 plus 10, 16 and 18 is 24, plus 10 makes a total of 34 square root 3. And now that's the final answer. Okay, if I want to multiply, I multiply the numbers first. So 2 and 4 makes 8, and then I multiply the square roots, so 3 and 6 is 18. Now in 18, a perfect square of 9 can be written. So this is 9 times 2. Square root of 9 is 3. So I have 8 times 3 times the square root of 2. 8 times 3 is 24 square root 2. And that's multiplying. For this one, I want to use the distributive property. So 4 square root 2 times 3 square root 2. Multiply 4 times 3 and I get 12. Square root 2 times square root 2 makes the square root 4. So 4 times that 2 is 8. And square root 2 times square root 6 makes 12. And then I want to simplify. So the square root of 4 times 12 is 24. And then over here, I can say this is the same thing as 8 times 4 times 3. And square root of 4 is 2 times 8, so I get 24 plus 16 times the square root of 3. And now that's in simplified form. Okay, This next one, find the area of a rectangle in simplest form with a width of that and a length of that thing, right? So the area of a rectangle is length times width. So I want to multiply my length times my width. So my length is 5 square root 3 plus 7 square root 5. And my width is 4 square root 6 minus 2 square root 10. So when I have a binomial times a binomial, I'm using the FOIL method. So my first 3 times 4 square root 6. So 5 times 4 is 20. And square root 3 times square root 6 makes square root of 18. If I do my outside terms, 5 square root 3 and negative 2 square root 10, negative 2 and 5 makes negative 10. Square root 3 times square root 10 is square root of 30. Inside terms, 4 times 7 is 28, and 5 times 6 is square root 30. And then my last terms, 7 times negative 2 is negative 14, and 5 times 10 is the square root of 50. So 20 square root of 18, that's going to be the same thing as 20 times the square root of 9 times 2, minus 30. In 30, 4, 9, 2. Well, we can combine these, 10 and 28. Positive 28 and a negative 10 will make positive 18, square root 30. And then 50, we can say that's the same thing as 25 times 2. So then simplifying, square root of 9 is 3 times 20 is 60, square root 2, plus 18, square root of 30. And then minus square root of 25 is 5 times 14 is 70. So this is going to be minus 70 square root 2. And that's a simplified it. Oh, sorry, not quite. 60 and negative 70 are both square root 2's, so I combine them and I can say that this is 18 square root 30 minus 10 square root 2. Okay, so that is example 4. So just a summary, some things you can do with radicals. If you have addition, so you have a square root b plus b square root b, c square root b, sorry, you can pull out the square root b and say it's the same thing as a plus c square root b. So that's what we were doing before. Like if I had 3 square root 2 plus 2 square root 2, we were essentially saying, okay, we're doing 3 plus 2 times the square root of 2. We were combining like terms and saying that this was 5 square root 2. So this is just a few extra steps than what we were doing. Okay, we can do the same thing with subtraction. And then with multiplication, we multiply the coefficients together, so that's the numbers in front, and then we multiply the radicands together and put them inside the root. And then we simplify anything that we can. And that is 10-3.